वेलकम बैक फिजिक्स एंथुसियास्ट इन अ वीडियो ऑफ ऑप्टिकल इंस्ट्रूमेंट। आज की वीडियो में अपन दो ऑप्टिकल इंस्ट्रूमेंट माइक्रोस्कोप, कंपाउंड माइक्रोस्कोप एंड टेलीस्कोप के बारे में समझेंगे। द रे डायग्राम एंड मैग्नीफाइंग पावर विच इज एन वेरी इंपॉर्टेंट टॉपिक फॉर सीबीएसई। लेट्स बिगिन विद दैट। ओके, सो सबसे पहले वी विल अंडरस्टैंड अबाउट compound microscope, which is there in your course. Only compound microscope is there. Compound microscope basically consists of two convex lens. It has two convex lens. One is objective lens and the other is eyepiece. So objective lens is basically close to object and second is eyepiece, which is close to eye. Now here the focal length of objective is very less than your eyepiece and the aperture of objective is also less than aperture of eyepiece. You have to remember that. Okay, and these two lenses are coaxially placed with each other. Okay, they are coaxially placed to each other. Coaxially means one lens and two lens. So now consider its ray diagram, which is very important. Consider a objective lens and an eyepiece. Eyepiece is definitely bigger than objective. Okay, now this is the principal axis. Okay, and let's consider that your object, where is my, okay, so consider this is an object. Okay, and from this a ray is coming and parallel to the principal axis and it passes through focus and the other ray passes through its optical center. Okay, the ray diagram should be very clean. Just remember that. Even in your answer sheet, just draw it properly. Okay, so they meet here. So at this point you will have your image from first. Now we are making this first for the image to be formed at least distance of distinct division. Okay, so the first is when final image is formed at least distance of distinct division. At least distance of distinct division, which is 25 centimeter, and obviously virtual, because we have to see the erect, not inverted image, erect image. So it should be placed in such a way, this final image A dash B dash should be formed that it lies beyond the focal length of this eyepiece. Why? Because if this image lies between FE and pole, then it will form a virtual image. Okay, and this is your objective focal length. Fine. And when these rays passes through the eyepiece and you see this again from eye and you extrapolate it in a backward direction, it somehow meet somewhere behind this object. Just remember that, which is your final image A double dash B double dash, and it is formed at a least distance of distinct vision. That is this distance, which is what? My final the image distance And why I put E? Because of the eyepiece is D. Okay. And this distance is what? UE, object distance. And this is VO. Okay, this is the image distance from objective. And this is UO, object distance from objective. E denotes eyepiece, O denotes objective, UV is object and image distance. Okay, it's a very simple, neat and clean diagram. Now, they have mentioned that the magnifying power for the magnifying power, it is basically the ratio of the angle, subtended by the image, final image placed at the image formed by the final image at the eye to the angle subtended by the object at eye when both final image and object are at least distance of distinct vision. When both are at least distance of distinct vision. Okay, that means your final image is this and it forms a angle. Let's take beta at the eye. So I have joined this, and always remember that this line passes through this. Okay, so this angle is my beta, and this object is also making some, when this object is here, let's consider, so this also makes some angle with eyepiece, with your eye. Okay, and that angle is alpha. You can redraw it like here, that let's take h be the height of object, h dash to be the height of image from objective, and h double dash to be the height of image, height of final image. And this is d distance, and this angle formed is basically my alpha. Okay, so what the magnification says, that is the ratio of the angle beta to angle alpha. Since the angles are small, so I can put beta as 10 beta and alpha as 10 alpha. So 10 beta is what? Perpendicular upon base. Let's take perpendicular to be this h dash and base to be this b dash e. So let's take a dash b dash upon b dash e whole over 10 alpha, and 10 alpha is h by d. Let's take AB and total distance what? B double dash E. And now we will put values. Okay, so if I put the values here, then your A dash B dash is basically H dash, and B dash E is this distance, which is UE, over AB is H, B double dash E is what? D. This is D, this is H. And you can say that this comes out to be h dash over h, that is height of image upon height of object for objective lens, and d by ue, ve by ue for eyepiece. So I can say that magnification because of objective is what? Height of image upon height of object, या फिर vo over uo, and magnification from eyepiece. I'm just putting the values here, then I will put using sign convention. And me is what? H dash over h double dash over h dash, or we can say that ve by ue, and v is d. So this is basically the product of magnification due to objective lens into magnification due to eyepiece, which we have already know that the total magnification from n number of lenses is nm. the magnification due to individual lens, and you have to multiply it. Now, we know D, but we don't know UE. So, using lens formula, thin lens formula basically, 1 by Fe is equals to minus 1 by UE plus 1 by VE. Okay. Now just put the sign convention Fe minus, let's take UE to be minus UE with sign convention. This is the formula just, and now I'm putting the values using sign convention. Okay, plus 1 and V is minus D. So 1 by Fe is equals to 1 by UE minus 1 by D. Bring 1 by D here. It becomes 1 by Fe plus 1 by D is equals to 1 by UE. And you can substitute the value of 1 by UE here. So M become H dash by H and D, and 1 by UE is 1 by Fe plus 1 by D. If you take D inside the bracket, then it becomes D by Fe plus 1. Fine. And here we can also say that if object is at focus, okay, then what? Then your UO will be equals to FO, and image would be formed at infinity, which should be L, that is length of microscope, because that is the infinity, that is the maximum length. So this magnification, which can also be written as VO by UO D by Fe plus 1, and now that can be written as VO is L, and UO since is negative because it is left, so I'm taking the minus sign here with sign convention. D by Fe plus 1. So this is again a formula, and here also with sign convention there is a minus sign if you are not using at infinity at some U, then VO by UO. Okay, so in this is the condition when the final image is at least a distance of distinct vision. Okay, and here if you want to calculate the length of microscope, then it is very easy. It's simply VO, the final image of this, plus UE. Okay, and if it is at infinity, then it is FO. The length can be calculated by calculating the final image due to objective length plus this, and if you are given the length, then you can minus length with U and you can get the UE. You have to understand the concept. Okay, the second thing is when final image is formed at infinity. When final image is formed at infinity. Okay, so if the final image is formed at infinity, then the object for the eyepiece should be at its focus. So you have to draw it, the ray diagram accordingly. This is the objective lens, this is eyepiece, and if your object is here, okay, then first this is my focus point of objective, and it passes the second ray will pass through optical center. This is optical center, and then the two rays, wait, let's make this. You have to be very careful with your ray diagrams. Very precise. Okay, let's. I think it's difficult. It's very slippery. No, it should pass through optical center and it should not go beyond. Okay, now this point is basically where my image is formed, A dash, B dash, and this is formed at my focus of eyepiece. And this is also UE. This distance is my VO. This distance is my UO. And the final image is basically formed at where? Somewhere at infinity. Okay, but you know that for the infinity we extrapolate it, and again we put it at a least distance of distinct vision. Now consider that some ray is coming from infinity, and let's make a parallel ray here, and it passes through this E, and we can say that this is my angle beta, and again alpha is between this object and I. So for my magnification, it's easy. You know that it is basically equals to MO into ME, right? For MO is basically VO by UO, and ME is basically uh, VE into UE, right? And now you can replace it. I'm not using sign convention here. Basically, VE can be written as, if you want, you can say that magnification due to objective lens. Due to objective lens, MO is what? L by FO, which we have done earlier, and due to eyepiece. Now what has changed here is your VE is basically infinity, but I'm using least distance of distinct vision because at that point only I can see. I can't see at the infinity. So it's D only, but your UE would be FE, the focal length. So your total magnification is minus L by FO into D by FE. Here both are negative, so it gives you positive because D is also on the left of lens and FE is minus of UE. UE is actually minus of FE, so both will cancel each other, and this would be my magnification when the final image is formed at infinity. And here if they ask for the length of telescope, then you can simply write what? VO plus UE, and here UE is FE. Simple. Okay, so this is microscope, basic two things, and this at infinity is also called as normal adjustment. Okay, now we will do for telescope, and in telescope there are two type of telescope, reflecting and refracting. The refracting has again two types, astronomical, in which we see that terrestrial objects, sorry, celestial objects, moon, stars and everything, and other is terrestrial telescope, in which we see the objects present on earth at a larger distance. And then we have reflecting telescope. One is Newtonian and second is Casgarian. They have only ray diagrams, no magnifying power, nothing. So yeah, let's check these four cases. Okay, so the next topic is telescope, and basically telescope are of two types. First is refracting, and in refracting you have astronomical, in which you see star, moons and everything, and next is terrestrial. Terrestrial, in which you see the distant object present on earth. Second is reflecting, in which they use mirror and they have Newtonian and Cassegrain telescope. Okay. So in our course, we have astronomical telescope, astronomical telescope again consists of two lenses, convex, okay, consist of two convex lenses, objective, close to object, and eyepiece close to eye. Here, basically the focal length of objective is greater than eyepiece, but both are comparable. They are not very small. Likewise, unlike the microscope one. And also the aperture of objective is greater than eyepiece. Okay, so just remember that. So again, we will do for two conditions. First, when final image is formed at least distance of distinct vision. At least distance of distinct vision. Okay, so here you have this objective lens, and this is eyepiece, not very small. And then you have this principal axis. And since we are talking about astronomical telescopes, so objects are definitely far apart. That means they are placed somewhere at infinity. So objects are at infinity. So the rays which are coming are parallel. So one parallel ray, next parallel ray, and the parallel rays basically passes when the object is at infinity, then the image formed is at focus. So this image is basically at FO, and this is also your VO distance. Okay, and UO is basically at infinity. Now, if the image is formed at normal distance, at least distance of distinct vision, then your FE should be behind FO, because the image should be between optical center and focus. Now the rays will come here. You have to adjust the lens accordingly so that the rays will pass from here and it goes there, and when you just extrapolate it, then the two rays will form somewhere here at least distance of distinct vision. Okay, so now if the rays are coming from object and make an angle alpha, then this should also be an angle alpha, and this ray will form an angle beta here. So the formula for magnifying power will remain same. This is my A dash, B dash, this is A double dash, B double dash, and basically this distance will be my UE. This distance will be my UE, and this is equals to VE. Fine. So the magnifying power here also, M is equals to beta by alpha, and since the angles are small, so I can write 10 beta by 10 alpha. Now then 10 beta is basically perpendicular upon base. This is perpendicular, and this is my base, which is A dash B dash upon B dash E upon 10 b alpha. For alpha, this and this distance, that is A dash B dash and B dash O. and here A dash B dash will cancel each other. Let's cancel each other. So your magnification will become B dash O over B dash E. Okay. And for B dash O, basically it is VO and B dash E is UE. And let's substitute the value of, and VO is also equals to what? FO, because your final image formed at F focus point. And for UE, we can use using Thielen's formula. So 1 by FE minus 1 by UE plus 1 by VE. But with sign convention, one by FE is equals to minus 1 minus UE plus 1 by VE is D minus. And this become, okay, and you can substitute it here. So if I check this magnification M, then VO is your focal length and U is minus UE because on the left with sign convention. And now you can put the value of UE here. So magnification will become minus FO. First, you will have to put the values as per 10 alpha and 10 beta and then using sign convention. And 1 by UE will become 1 by FE plus 1 by D. If you take FE to be out, then it become 1 plus FE by D, which is a magnification in at least distance of distant vision for telescope. And you can see here that M is inversely proportional to FE. Therefore, the focal length of eyepiece should be smaller to get high magnification. Sorry. And here, if you want to calculate the length of telescope, so it is basically VO plus UE, and VO is focal length. Okay. And second is when final image is formed at infinity, then in that case, this is your objective lens. Oh, sorry. It should be big. This is your objective lens. This should be your eyepiece. And your object is placed at infinity again. At infinity. So the rays coming should be parallel. And they somehow meet at focus FO. And if the final image is also at infinity, then this point is also your FE, right? In that case, your final image can be formed at infinity. So this, okay, move out, and this somewhere goes at infinity. Fine. And let's suppose any ray coming from infinity will make an angle beta with your eye, and similarly an angle alpha with eye. Okay, so this distance is your VO, UE, and UO is at infinity and V is at infinity. So here basically a magnifying power again will become beta by alpha, which is 10 beta by 10 alpha. And 10 beta is what? Let's mark it as A dash B dash. So 10 beta is A dash B dash over B dash E base upon the height upon base, and alpha is again height upon base, which is A dash B dash over OB dash. So your magnification will become A dash B dash over B dash E into OB dash over A dash B dash. So OB dash will be your FO, and B dash E would be minus FE because in left. So with sign convention comes out to be minus FO by FE, which is a magnification when the final image is formed at infinity. And if you want to check the length of telescope here, so it's simply FO plus FE. Okay, which is important. Okay, so now third topic is basically reflecting telescope. In this, you only have to remember the ray diagram just. So for Newtonian, what Newtonian has done in this, he basically used a concave mirror. This is a concave mirror, and he showed that some parallel rays are coming on this from distant object, and after reflecting it converges somewhere, and to obtain this he put a plane mirror here. This is a plane mirror, and after reflecting from the plane mirror, it goes somewhere here, which is captured by my convex eyepiece lens. This is convex lens, which is basically my eye lens, eyepiece. Okay, so he uses a concave mirror and a plane mirror, and in Cassegrain telescope, he uses a concave mirror. Again, some parallel rays coming on this mirror, and this is my concave mirror, and after reflecting here, it uses a convex mirror like this, and it diverges, and this is your convex mirror, and again here is my eyepiece. So here he use a convex mirror, and there he use a plane mirror. Okay, so there are two types of reflecting mirrors, and then refracting telescope and microscope, and you have to consider two conditions of at least distance of distant visions and at infinity. Okay, so this is the optical instrument topic, which is very important, and thank you for watching this video. Do like, share and subscribe for more such videos.